This is Science Friday. I'm Ira Plato, and it's the moment you've all been waiting for. It's time for our Charismatic Creature Carnival. Joining me today, as always, is our Charismatic Creature correspondent, SciFri producer Kathleen Davis. Hi, Kathleen.
Hey, Ira, I'm very excited to be here.
Me too. So we're kicking off the carnival today. Tell us a bit about what we've got in store.
So, over the next 3 weeks, we are shining a spotlight on 6 audience-suggested charismatic creatures. And by charismatic, we mean a creature that's overlooked or unfairly maligned by the general public, that once you look a little bit closer, it has an undeniable charm to it.
Hey, that sounds like you're talking about me there, I think.
I'm not kidding. Somebody actually did suggest you as a charismatic creature.
Is that right?
But we had to take you out of the running, unfortunately. That also means that I don't want to say that. That also means that undeniably cute creatures like koalas or pandas or capybaras, they don't belong here. We're highlighting animals that you might write off at first, but they deserve a closer look, you could say. And we're going to do these head-to-head friendly battles between 2 creatures. Each creature has an expert representative who's going to try to convince you and our audience that their creature is the most charismatic of each round. We're going to have a few weeks of voting, and then at the end of the carnival, we will have our very first true inductee into the Charismatic Creature Corner Hall of Fame.
Okay, enough talking. Tell us about how these creatures got chosen.
Yeah, so we got dozens of really great suggestions from our audience members. And then we had the SciFri staff vote on their favorites, and we were able to narrow them down to 6. So Ira, are you ready to learn what creatures are part of this fall's Charismatic Creature Carnival?
More than ready. Hit me.
Okay, so your 6 possible champions are the Eye, the Hellbender, the Mantis shrimp, the opossum, the pigeon, and the shoebill stork.
Okay. Those are some great candidates. Let's kick off our first matchup. We're going to have one per week for 3 weeks. So which creatures are we going to hear about today?
Okay, so for our first matchup today, we are heading into the water. So I would like a drum roll, please. In one corner, we've got the Mantis shrimp. This creature was suggested by Garrison from Charlotte, North Carolina. He left us this message on our SciFri VoxPop app.
I'd like to nominate the Mantis shrimp for the Charismatic Creature Carnival. The Mantis shrimp has a few features that make it worthy. For one, it's got an incredibly powerful punch capable of producing heat and light. It's got some of the most complex eyes in the animal kingdom. And the charismatic bow on top is that it is certainly colorful enough to attend a carnival in style.
That's a pretty good argument.
Pretty good.
And representing the Mantis shrimp in our Charismatic Creature Carnival is Jason Dinh, Ph.D. candidate in biology at Duke University in Durham, North Carolina. Welcome, Jason.
Thanks for having me.
And in the other corner, we've got the Hellbender Salamander. This creature was suggested by listener Timothy from Pittsburgh, Pennsylvania, who wrote us on Twitter. He said, "Everyone now knows axolotls, but here in Appalachia, we think bigger, offering our Hellbender Salamander." And defending the Hellbender in our carnival is Lauren Diaz, Ph.D. student in fisheries science at Oregon State University in Corvallis, Oregon. Welcome, Lauren.
Thank you. I'm so happy to be here.
Oh, we're happy to have both of you. I can't wait. We're excited to have you all here. And just a note, this segment was recorded in front of a live Zoom audience. And if you'd like to join us live on the next time we do this, to find out how you can join a future live radio recording, go to sciencefriday.com/livestream. Okay.
Right, you want to kick things off?
There we go. I'm ready to kick things off with okay, let's go first with a basic description of these creatures. What do they look like? Where do they live? Jason, you're up first. Start with the Mantis shrimp.
Sure. So I can tell you a little bit about what they look like, and then I can tell you a little bit about their evolutionary history to kind of contextualize our conversation. So mantis shrimp are about 450 known species of crustaceans in this group called stomatopods. They live in the tropics and subtropics in burrows on the seafloor. And these can be either constructed burrows out of sand or they can be from natural crevices and things like corals or rocks. I actually brought one for the live audience to see. I'm sorry for the radio audience. But they look kind of like that, and we keep them in little burrows. And so they're pretty small. They could be anywhere from less than an inch to over a foot, but generally they're around the size of a cigar or your finger. And they could be anywhere from just plain beige to just extremely gaudy and colorful. They kind of look like lobsters in the back, but in the front, they're just totally unique. So they have these huge eyes that kind of just are always moving independently from one another. They have these antennal scales that flare out from the sides of their heads that are super colorful. And they have these really fast feeding appendages that they fold up underneath them, like a praying mantis, which is how they get the name mantis shrimp. These appendages kind of look like legs, but they're actually mouth parts, which is how they get their name stomatopod, which means mouth foot. And they kind of come in two flavors: spearers, which have super long spiny tips that they use to capture soft-bodied prey, and smashers that have this enlarged calcified heel that they use to smash apart hard prey. And so these really bizarre, unique animals, and that's partially because they have such a separate evolutionary trajectory from any other animal that's alive today. So they diverged from all the other crustaceans that we know of about 340 million years ago. This is around the time that all the continents were coming together to form Pangea. Tetrapods barely had left the water at this point. So it's a really long time ago. Around 200 million years ago to 100 million years ago, we get rapid diversification into all the mantis shrimp that we know today. And so this is still a really long time ago. Dinosaurs were roaming the earth, Pangea was spreading apart, and we were getting all these new coastal habitats for mantis shrimp to diversify in. So just keep that in mind as we're thinking about how unique these animals are today.
Jason, thank you for that description. And for a second, I thought you were going to go through the whole 200 million years step by step there. So, Lauren, I think you've got your work cut out for you with your Hellbender. Give us your best description of the Hellbender. I mean, it sounds like a motorcycle group to me, but tell us what it is.
That would be a really good name for a motorcycle group. So Hellbender salamanders really broadly are in the giant salamander family, Cryptobranchidae, which are the largest amphibians on Earth. And actually, hellbenders are North America's largest amphibian. So I like to describe them mostly as kind of like a big slimy rock. That's what they look like to be. They're really good at camouflage. They can reach up to about 2 feet long, which is really, really big. Have this really like flat, wrinkly, brownish, splotchy body. So when you see them underwater, it's hard to see them, especially from like above the surface. They just look like another rock. These beady, tiny little eyes. A big paddle-like tail for swimming, keratinized toes, which truly the only salamander I know that has pretty much fingernails. And they use that to kind of crawl along the rocks and really hold their grip. Let's see what else. They are fully aquatic, so and don't have external gills. So that's actually where the name cryptobranchid comes from, hidden gills. And as far as their habitats, they live under boulders in rocky, clear mountain streams with fast flowing water. Throughout Eastern North America, the best populations are around the Southern Appalachians, like North Carolina, Tennessee. There's other populations up north around Pennsylvania and Ohio that are still, existent. And then there's also a disjunct population in Missouri, which is considered a critically endangered subspecies. And so their need for clean, fast flowing water is, spoiler alert, a bit of a problem these days. So yeah, I think that's it for the description.
That's a great description.
Yeah, terrific.
Very, very descriptive. Now, Catherine, one of our listeners from the Hudson River, has a question about how the Hellbender got its name. Catherine, would you like to ask that question? Well, I can ask the question.
Of high tech.
Well, the question, spoiler alert, is why is the Hellbender named a Hellbender?
Yeah, that's a question I get so often because it is such a weird name to give an animal. But it comes from probably the fact that they are considered traditionally ugly to a lot of people. I don't think so, but a lot of people do think that. And so back in the day, the first time people ever saw them, it was like, oh man, this creature from hell bent on returning. That's like the thing that everybody says. But we actually have no idea, honestly.
Now, one other thing that I wanted to ask about hellbenders. So one of my favorite things about them is that they have a lot of nicknames. So I've heard snot otter, devil dogs, lasagna lizards. Do you have a favorite
Lasagna
nickname?
lizards?
I know, I know.
Wow.
Do you have a favorite nickname, Lauren?
Yeah, I actually, lasagna lizards is probably my favorite. And they're called that because they are so wrinkly. So the sides of their body look like the sides of a lasagna, which is so creative. But yeah, snot otter is probably the most common one. I have also heard alligator for, since they're up in Pennsylvania, Ohio region. But yeah, really fun nicknames. People love that.
Wow, that's terrific. Yeah, I love something with a lot of names. I'd like to go back to something Jason said about the mantis shrimp. The color can be really incredible. As our listeners said, they really do seem decked out for a carnival. What role does color play for all of these creatures? What's happening with the mantis shrimp? Why does it have an incredible amount of color to it?
Yeah, so mantis shrimp vision is kind of incredible on a couple of fronts, but color is one of them, and another one is what we call polarization, which is a feature of light we can't even see. So I'll start with color. Mantis shrimp have a lot of behaviors that they use color for. And so different mantis shrimp will be different colored, different species will be different colored so that they can tell each other apart. Can also use colors as kind of signals of quality. So there is a species of mantis shrimp, for example, that has a spot on that beating appendage. And it turns out the darker the spot, the harder the shrimp can hit. And so it can be a signal to competitors about how good of a fighter they are. They also use them in mate choice. So there's been some good experimental work showing that if you mess with some of these color patches, females will have trouble picking out mates. And they have a totally unique way of seeing color, which is what's so cool about them. So mantis shrimp have 12 types of color receptors. We have 3, red, green, and blue. Your dog has 2. Birds have 4. They have one that can see into the ultraviolet. And mantis shrimp can also see into the ultraviolet, but there's this, kind of crazy question of if birds can do it with 4, why do mantis shrimp have 12? And so one theory that people had was that, well, maybe if they have 12 color receptors, they can better discriminate between colors. But experimental evidence in the last 10 years has shown that they're actually not that great at discriminating between colors. They're about 5 times worse than people are. So to this day, it's still not really clear why they have 12 cones, and there's a lot of ongoing work trying to figure this out. But the prevailing theory so far is that it's a way for them to really quickly identify colors. So when we identify a color, we have to basically in our central nervous system compare the stimulation of all 3 types of our cones to figure out what color that is. But if a mantis shrimp, for example, just has a yellow cone, it can just have a very quick lookup table and say that's yellow without having to do any cross cone comparisons. And so if you thought, having a unique color vision, that's not enough to be charismatic, it turns out that mantis shrimp can also see a totally different type of light than we can even fathom. So they see what's called polarized light. A lot of arthropods and invertebrates can do this, but as I'll mention in a second, mantis shrimp are really exceptional in this regard. So you can imagine most light coming at you vibrating in all sorts of different directions. But sometimes when light bounces off the surface, it becomes what's called polarized. So it goes in one plane only, so up and down or left and right. Mantis shrimp can actually tell what angle polarized light is coming at, and they can use it for communication. So they have different parts of their body that will reflect polarized light, and they can also use it for navigation. So they have polarization patterns in the sky that they can figure out what direction they're going in. And so, like I said, this is not particularly unique to mantis shrimp. A lot of invertebrates can do it. But the really cool thing that mantis shrimp can do is that instead of seeing linearly polarized light, they can also see what's called circularly polarized light. So linear polarized light goes up and down or left and right. Circularly polarized light kind of comes at you in a circle, spiraling in a circle. And last I checked, mantis shrimp are the only animals we know of that can do this. So this is a really interesting communication channel because it's kind of totally private to them. No one else that we know of can possibly see this. And they have circularly polarizing patches on their tails and legs that they use to advertise where their burrows are and to fend off other competitors.
Wow, great description. We have a question from an anonymous question from a 3-year-old nature enthusiast. Whoa. What do hellbenders and mantis shrimp eat? Let's go to hellbenders. What do hellbenders eat?
Hellbenders, they mostly specialize on crayfish, but they pretty much eat anything that is easily catchable and can fit in their mouths. That just mostly happens to be crayfish where they live. They just kind of slurp them up whole like a vacuum sometimes when you're handling, when you can even feel like a hard insect in its stomach since the rest of it is so soft, which is very weird. But yeah, they're also quite cannibalistic, which is kind of a fun fact. They eat other smaller hellbenders and larvae and eggs and other small salamanders. A collaborator of mine even found a hot dog in the stomach contents of a hellbender once.
Oh, no.
If it can fit in its mouth, it'll eat it.
Wow, wow, a hot dog. Yeah, and as for the mantis shrimp, does it have a favorite food?
Yeah, so mantis shrimp are a little bit of generalists, but also kind of specialized based on that feeding appendage, right? So the spearers kind of specialize on soft-bodied, fast-moving prey. So things like fishes, relatively soft shrimps, polychaete worms, whereas the smashers tend to go for more slower-moving, hard-shelled, highly defended prey that they can smash open. So these are things like bivalves, they can get slow-moving crabs, and they can even break open snail shells, which are kind of like the canonically unbreakable material of the natural world.
I want to get to why these creatures are so charismatic, just going right to the chase. But Lauren, I want to start with you and with hellbenders. So you're a freshwater ecologist, and I know that that is the habitat of these hellbenders. Tell us a little bit about the role that hellbenders play in the ecosystem.
Sure. So like I said, they eat mostly crayfish and pretty much everything smaller than them. So they act as a top predator in small stream systems. So they're a top predator. So because they're a top predator, they're suspected to have some control on lower trophic levels in the stream. Not many things eat them besides the occasional otter. And also in a lot of small streams, they can exist in really high biomass. Like just think of a small little, like maybe 10 meters across stream, every boulder with a huge slimy salamander under it, pooping and laying eggs. So it's suspected that they also maybe have some role in stream chemistry. These things are really hard to study, so we don't actually know for certain yet, but there are a lot of people studying that currently. Clemson University is currently working on these questions. So yeah, I'm excited to see what they figure out.
Yeah, let's talk about a bit about mantis shrimp. People may have heard about these before because they're famous for their punches. I mean, tell us a little bit about what the heck is going on with their amazing punching power.
Sure, yeah. So I'll talk mostly about the smashers because those are the ones that are just like the most amazing kinematic performers that we know of so far in the mantis shrimp. So mantis shrimp achieve one of biology's just highest acceleration movements. They can exceed what humans can engineer both in terms of size and speed. And so they're remarkable on a couple of fronts. They're really brief. So an individual strike lasts about 3 milliseconds. I would say that's like in a blink of an eye, but that would be a total understatement. A blink of an eye takes about 100 times longer than that. Their peak speeds reach that of a car on the highway, around 70 miles per hour, and they're accelerating probably around equally to a bullet coming out of a 22 caliber rifle. When they actually strike something with this strike, their peak forces are equal to that of a hyena, which are these animals that have specialized skull structures to literally crush bone, and they're doing it at such a different size, right? So mantis shrimp feeding appendages are less than a gram. They're about the mass of 2 toothpicks. Hyenas are about 20 kilograms, so that's a 20,000-fold different in mass and producing the same peak forces. They're doing it by using a series of springs and latches. So instead of actuating their movements with muscles, they're actually actuating it with springs. And so this is similar to using a bow and arrow. If you wanted to throw an arrow using just your muscle power, you, or at least I, wouldn't be able to throw it very far or very fast. But if you kind of just took that same energy, loaded it into a springy bow, latched it until you wanted to release it, and then let go, you could get the arrow to go really far and really fast. And so that's basically what mantis shrimp are doing. They have these really high force muscles inside their feeding appendage that they use to slowly load all of these spring-like elements inside their feeding appendage, things like deforming their cuticle. And they hold it in place with a latch until they're ready to strike. And as soon as they let that latch go, a huge amount of power delivery goes to this rotating hammer that they use to smash their targets. And they do it for a couple of things. They use it to smash prey, like I've mentioned. They can break open snail shells. They actually hit the shells so hard that they're boiling a tiny layer of water on top of the shell. It's a phenomenon called cavitation. They're literally ripping the water molecules apart into water vapor. And when that bubble collapses, it's super energetic. It creates super loud sounds, tiny flashes of light and heat equivalent to that of the sun. And the force of that collapse can actually exceed the force of the initial strike of the hammer. So with one strike, they get 2 punches to break open these shells. And they're super clever with how they actually use the strikes. So they'll target the snail right at the opening where they're most likely to break it open and get the meat. If the snail's too tall, they'll do this kind of like rotation thing, and they'll hit them at the top where they're most likely to get punctured, or where they're most likely to get fracture. So they're hitting hard and they're hitting really cleverly.
That's so incredible. We got a listener question from Christopher, who has a question about the power of a mantis shrimp's punch. Go ahead, Christopher.
Hi, Jason. Yes, my question is, if the mantis shrimp was human-sized, how much power would the punch pack?
So that's a difficult question to answer because one of the principles of these really small, really fast-moving things is fast-moving animals is that the smaller you are, the better they work, right? So typically these kind of spring-actuated systems only work at a couple grams. And so if you were the size of a human, you wouldn't actually be able to use these spring-powered movements. Actually, the largest mantis shrimps that we know of use these spearing strikes that are totally powered by muscle. They're not very fast, they're totally powered by muscles, and they don't use any spring-like elements in their arm.
That's really amazing. Let me ask you, if their punches are so strong, how do you keep them from breaking the glass in your laboratory? Well, you held one up before. I mean,
luckily we have
punch its way out of the aquarium there.
Yeah, so there's some anecdotes of like really large mantis shrimp that are capable of smashing aquaria. Luckily in our lab, we work with, mantis shrimp that are only 1 or 2 inches. And so we've never had an experience, at least that I know of a mantis shrimp totally destroying any aquaria.
Wow, we have a question from Denise. Go ahead, Denise.
Oh, I'm here now. Can you hear me?
Yes.
Sure. Okay. Yes, I had 2 questions. One was with the mantis shrimp. What advantage would it have for seeing polarized light?
Yeah, so that's a great question. There's a couple of answers I can give you. One is that in the ocean, the light regime that you're getting totally depends on the depth, right? So the wavelengths that the ocean's actually scattering can change the light regime. So you lose reds really quickly, for example. So if you're looking at just colors, for example, that we can see, it'll change a lot depending on how deep you are as the tides go up, as the tides go down. Polarized light's a little less sensitive to depth, and so it can give you a more temporally reliable signal. Another reason is that in terms of circularly polarized light, like I was saying before, they're one of the only animals that we know of that can detect this. And so it's a totally secret communication channel. You can have all these super flashy displays, but no one else will be able to see it except for your intended receivers. There won't be any eavesdroppers in your communication channel.
Wow, I love it when the questions get really geeky and we get
and then Denise,
get into the weeds.
You had another question about hellbenders, right?
Yes, I did. So you mentioned, Lauren, you mentioned that hellbenders are cannibalistic. So I'm wondering, I've heard this also about Cape frogs in Australia, and I'm wondering, why would animals evolve to be cannibalistic? Because it seems like they would kind of be their own worst enemies.
Yeah, that's a really good question. And I don't know if I have a super great answer. What I would assume is that probably, back in the day when there was a lot more of them, it didn't really make a dent in the population. Evolution works at the population level. So, back in the day, it would be advantageous to eat another hellbender's eggs if you just needed to increase your fitness, because it wasn't actually like hurting the population of hellbenders in general. And you just encounter a lot more of them, but they probably don't find each other as often now to eat each other. And everything is a lot more spread out. So I don't know if it's, been reduced over time, but that's what I would think.
Sort of a riff on the old song, if you can't be with the thing you eat, eat the thing you're with.
I don't know about that one.
Let's go back to mantis shrimp. I hear that you have an interesting way of, or they have an interesting way of navigating their surroundings. Tell us about that.
Sure. So mantis shrimp live in these burrows. And a lot of times when you're seeing them snorkeling or scuba diving, you'll just see their eyes popping out of the burrows, but they do have to leave. So So they have to find food and they have to find mates. And it turns out when they go to forage, they kind of take this like very circuitous, zigzagging path, kind of searching for food. But when they find their food, they're able to make a direct path back home. And so they're able to do this through a phenomenon that we call path integration. So basically, as they're roaming around, they have to have some sense of their compass direction, and they have to have some sense of how many steps they took, so like an odometer. And at the end of their path, they'll be able to integrate all of these tiny little movement vectors that they made into the most direct path home. And they do that using sun cues. So the position of the sun can give them some insight into which way they're going. It's another advantage of seeing polarized light. You get these patterns of polarized light in the sky that they can use to figure out what direction they're going. And they also use just internal cues about how far they've gone and where they've gone. It's a little error prone, but they can also integrate this information with kind of local landmarks that they know that are near their burrows. For example, if your burrow is under very conspicuous coral and you're, heading a little bit off, you can correct yourself and say, oh, that coral is near my home. I can go right there.
I want to we're getting to the end of our time, unfortunately, but I want to get one more Hellbender question in that's more specific. It's my understanding that there's some really interesting lore around them that maybe had to do a little bit with their population decline. Lauren, can you tell us a little bit about that?
Sure, yeah. Well, I'm not sure how big of an issue this is, if it's actually contributed to population decline, but it is definitely something that happens. So they have kind of a bad reputation with fishermen. And I'll start by saying that they're totally 100% harmless, unless you're a hot dog, apparently. But most of it seems to just be superstitious, like hellbenders are bad luck for fishing. Fishermen catch them a lot. And a lot of the time they don't make it off the hook alive. But also a lot of people think that hellbenders eat popular game fish like trout, when in fact they probably rarely interact. Hellbenders are benthic creatures. So they're pretty much only walking around on the bottom, and trout are, up higher in the water, obviously. So if anything, seeing hellbenders is a sign that a stream is healthy and thriving and is probably full of trout. So yeah, that's a misconception that can hurt them a lot of the time. A friend of mine was actually radio tracking some hellbenders in Tennessee, and found one of his animals on the bank with a big stab wound on the top of its head, which is really sad. And probably due to one of these misconceptions. So, and with these long-lived animals, they live up to 30 years. I forgot to mention that earlier. Each individual makes a difference. So it's sad to see the consequences of their inaccurate representation, and I hope to change that today.
Wow, so much good stuff, so much to digest about these two charismatic creature candidates. It's time to hear your final arguments, your best and final arguments for why your creature is the most charismatic. Jason, let's start with you.
Sure. So I think that mantis shrimp are the most charismatic for two reasons. One is that they're totally unique, and that's due again to their evolutionary history. And two is that they're just totally awe-inspiring animals. Like, there are a lot of animals that do one or two really cool things, but it seems like wherever you look, the mantis shrimp is doing something kind of remarkable, whether it's like a totally unique way of seeing or just having devastatingly fast strikes. And so in this way, it's kind of like a glimpse into nature's evolutionary playground, where we can find some really unique solutions to evolutionary problems. And as scientists and engineers, the more we learn about what mantis shrimp do, it seems the more we're learning how to apply these to our own science and engineering. So there are some engineering groups working with the lab that I'm in to look at how the individual components of a mantis shrimp's feeding appendage can inform really small and fast robots. There are material scientists looking at how mantis shrimp can break open snail shells, but not damage their own hammer in the process to make impact-resistant materials. If you remember cavitation, it happens everywhere when you move really fast. Ship propellers cavitate all the time, and it destroys ship propellers. It can blow the cover of submarines, but mantis shrimp, despite being able to cause cavitation on these snail shells, almost never cavitate on themselves, even though they're moving incredibly fast. And so there's just so much behavior and morphology that we're learning about the mantis shrimp, and I think we're just starting to scratch the surface.
Okay, Lauren, it's your turn. Very different creatures, but they're exciting in their own ways. Let's hear your argument in favor of the hellbender.
Yeah, if the name Snot Otter didn't already convince everyone that they're the most charismatic creature, I would say that they're also incredibly unique. Pretty much a living fossil, a relic of the past. There's only 3 giant salamanders on Earth, and we are lucky enough to have one of them. And they also, to me personally, represent this amazing and fragile and sensitive and beautiful habitat. There's nothing more beautiful than like being underwater in a clear mountain stream and seeing all these super cool fish and insects that nobody ever really gets to see. And to me, Hellbenders are kind of a poster child for that environment and are a big reason why I love them. And they can act as an umbrella species. So when you protect Hellbenders, you are basically protecting everything else in the stream. So in that way, they're like the poster child for stream biodiversity and conservation to me.
Two great arguments. And Ira, this is normally the time where I'll ask you to choose whether you think these creatures are charismatic or not, but because this is the Charismatic Creature Carnival, we already know that these are very charismatic creatures, and we're going to do things a little bit differently.
Glad you're taking the pressure off of me. All right, so what are we doing this week?
So this decision is now in the hands of our listeners. So we want you to vote for which of these creatures is your favorite that we talked about today. Which one do you think is the most charismatic? We want to hear from you. So to vote throughout our carnival, not just today, you're going to go to sciencefriday.com/carnival. Voting is now open for this first matchup until next Wednesday at 10 a.m. Eastern time.
Let me repeat that important link at sciencefriday.com/carnival. And I am on the edge of my seat to see what you listeners choose, because this is exciting. I want to thank our experts this week. It was great to learn more about these charismatic creatures. Jason Dinh, Ph.D. candidate in biology, Duke University in Durham, North Carolina. Lauren Diaz, Ph.D. student in fisheries science, Oregon State University in Corvallis. Thank you both for joining us. How about a round of applause for our contestants?
You'll just have to imagine the applause. Thank you both so much for joining us.
Thanks for having me. Vote Mantis Shrimp.
Yeah, go Hellbenders. Thank you so much.
Kathleen, okay, who's in store for... Okay, Kathleen, who or what is in store for our Charismatic Creature Carnival next week?
So next week we are going... Let me do that again. Next week we are going mammalian. It's a head-to-head match between the opossum and the eye.
Yes, Captain. Oh, the creature. I see what you're saying. These are some funky creatures.
Yes. And so our listeners can join the behind the scenes recording of that segment and get the opportunity to ask our experts questions. That's happening next Wednesday at 4 p.m. Eastern time. Go to sciencefriday.com/livestream to sign up.
Thank you, Kathleen. Terrific job today.
Thanks, Ira. Excited to keep the carnival going.
Yeah.